Good morning. Today is Thursday, December 17th, 2020. Our I can for today is I can create triangles given specific attributes. An attribute is something that describes something like a characteristic. I could give you some attributes and you could guess who I was thinking of. I'm thinking of somebody furry. I'm thinking of somebody who barks during my meetings when I'm recording sometimes. And I'm thinking of somebody who likes to sleep a lot. And all of those clues made you think, oh, that's Samson. Right, because Samson's right here sleeping like normal, but I'm sure he'll bark while we're recording. So here we go. Let's try to make a triangle that has 3 different angles. So we're going to make a triangle that's known as scalene obtuse. So that's going to be its first and last name. It has to be scalene. You could be scalene, and have no equal sides. So it's going to have no equal sides, and it has to have an obtuse angle. I'm going to start with the obtuse angle. I'm going to make 1 point, and then another point on the same line, and 1 point up here by my 1. Pull out my handy dandy Cam Jansen book, and I'm going to use my straight edge to connect the points because I want my triangle to look as nice as possible. This will help me when I'm trying to remember which triangle is which. All right, the first thing I made was I made an obtuse angle. Do you see this angle right here? That is a big old angle. I could tell you that measures 110 degrees. Is that bigger than 90? Yes, so it's an obtuse angle. Now, I'm going to tell you that this angle down here is 30 degrees, and this angle up here is 40 degrees. Now, something very cool about angles and measures is they're always across from a side. The biggest number is across from the longest side, and the smallest number is across from the smallest side. So this triangle makes sense. This triangle would have 0 lines of symmetry because it has no equal sides and no equal angles. Let's try another one. This time I want us to make an isosceles. Remember, 2 eyes, 2 sides. 2 eyes, point to your eyes. 2 eyes, 2 sides. It's isosceles. This is going to be an isosceles obtuse triangle. If it's isosceles, I know it has 2 equal sides, but it still has to be obtuse. It has to have an obtuse angle. So this is what I'm going to do. I'm going to put a point up here, and then I'm going to make a point. I went down 2 lines and over 2 lines. They're about the same distance away. I'm going to connect those 2. Oops, I almost forgot my handy dandy straight edge. When I use my straight edge, my triangles come out much nicer, and they don't look like scribble scrabble. All right. This could be an isosceles obtuse because these 2 sides are equal. This is my obtuse angle. Let's pretend that it was 100 degrees. Is that bigger than 90? Yes. So the number does matter because if the number is bigger than 90, we know it's obtuse. If it's smaller than 90, we know it's acute. And if it's exactly 90, it's a right angle. Now, if these are isosceles, that means these 2 angles are equal to each other because this side is this angle and this side tells us this angle. I know that both of these would be 40. And if I have 40 on this side and 40 on that side, what do we know about a line of symmetry? I could cut this triangle right down the center and it would give us 1 line of symmetry. Let's try to make another triangle. This time I'd like us to try to make a scalene obtuse, but I'm going to try to trick you with this one. I'm going to make it look like a different triangle. I'm going to make it look like a right triangle. But there's going to be a clue, one that I want you to know and look for so that you know how to tell if it's really scalene or isosceles, and if it's really obtuse or if it's a right. Because when I look at this triangle, we're making it look like it's a right triangle. Doesn't it look like a right triangle? It sure does. But guess what? I'm going to tell you this angle right here measures 91 degrees. If it measures 91, could that be a right triangle? No. Then I'm also going to tell you that this part down here measures 45 and this part up here measures 44. So are my angles equal? No. So this is an example of a scalene obtuse because it has no equal sides and no equal angles, which means it has no line of symmetry. Every time, so this is a good rule, we can write it right here since I have a little bit of space. Scalene triangles have no line of symmetry. Isosceles triangles, two eyes, two sides, two eyes, two sides. Isosceles, two eyes. Isosceles triangles have one. That's a good one to remember and one common that fourth graders mistake, so be careful with it. Isosceles triangles have one line of symmetry. Okay, let's try a different triangle. Let's see, I'll tell you what, I'm going to draw the triangle. Let's see if you can identify it. So here's your triangle. I'm going to start with a point up here and 2 points about the same distance apart. I'm going to use my handy dandy straight edge and I'm going to connect all my points together. And I'm going to realize that I need to label these angles because just looking at it, I would be guessing what kind of triangle it was. I'm going to tell you that the top angle measures 58 degrees. And I'm going to tell you this side measures 61 and this side measures 61. Are these angles equal? Yes. So if the angles are equal, then these sides are equal. And if we have two equal sides, two eyes, two sides, what's the name of this triangle? It's isosceles. Good. So this is an isosceles what? So isosceles told us from the sides. Now we have to talk about the angles. Is there a right angle? Is this isosceles right? No. Is isosceles obtuse? Is there an obtuse angle? No. So this is an isosceles, acute triangle. And if it's isosceles, how many lines of symmetry do we have? One line of symmetry. Good work. All right, let's make another one. Number 5. I'm going to try to make the most perfect triangle I could possibly make. When we see perfect triangles, sometimes I think of a piece of Toblerone, some delicious chocolate. If I see a perfect triangle like this triangle has 3 equal sides, which means it also has 3 equal angles. Well, if I have 3 equal sides and 3 equal angles, I also have 3 lines of symmetry. So what's the name of this triangle? Equilateral, acute. It's equilateral because all 3 are equal. It's acute because all of them are acute angles. And an equilateral acute would have 3 lines of symmetry. Because I could split it right here, I could split it right here, and I could split it right there. Those would be my 3 lines of symmetry. Now, what if I had a triangle that had a right angle in it? It gives you a good clue for its first name. I'm going to make this a little one so I can fit one more below it. What kind of triangle is this? Well, it would be right because there's a right angle. This would be a right what? Let's look at the sides. Are there 3 equal sides? No. Are there 2 equal sides? No, there are no equal sides. So it's a right scalene. And if it's scalene, we know it has 0 lines of symmetry. Okay, last one in our notebook. Here's number 7. I'm gonna make this one a little bit bigger than the last one. I gave you 2 clues. This is your first clue. So we know it's a right triangle. This is your second clue. That tells you that those 2 sides are equal to each other. 2 eyes, 2 sides. What's the name of this triangle? This is a right isosceles. And if it's isosceles, that means we have 1 line of symmetry right down the middle. Oops, let me slide my notebook up so you can see that. There we go. Nice job. So take your time, finish your notes. Then we'll be turning in your green book to do some practice today. Work hard, take your time, use your notebook to help you find the answers. Have a good day.